Good morning, everyone. Today I will be presenting on a seminar of design of clocked sequential circuit to detect a given sequence, like with or without overlapping. In both conditions, this topic is very important. In digital system, design and forms the basic for sequential detection using in communication and control systems. Hello, I am JB Ganesh from Department of Electronic and Communication Engineering from the VVIT College. Today I will be presenting about this topic where introduction of sequential circuits. Like we see in the diagram, input and output. The combination circuit is a sequential circuit is a digital system whose output depends only on the present input but also on previous states. It mainly uses flip-flops and memory elements and is synchronized by a clock signal, where this clock signal is a mediator which converts input and it changes the output. There are two major types, synchronous and asynchronous circuits, where synchronous circuits clocked and asynchronous is unclocked. Here we will deal with clocked sequential circuits where all changes happen at discrete clock, whereas in the edges we all changes happen to the discrete clocks. Next, in another slide, we seen that what is sequential detector. By the diagram we can see that a sequential detector is a sequential circuit that looks for a specific pattern of bits within a serial data stream. Where we can definition or example pattern on real applications uh, are there in this sequential detector. Sequential detector is a clocked digital circuit that continuously monitors a serial input bit stream and generates a high output signal when it identifies a specific predetermined bit pattern. This circuit finds critical applications in digital communication systems, data and decoding protocols, and error detection mechanisms. And next is the basic concept of sequential detection. It is that the working principle is simple as arrives one after another. The detector continuously checks whether the recent bit matches the target pattern, where detector continuously checks in the whether recent bits are matched the target pattern. When a complete match occurs, the output pulse is generated. It is a design decision where whether overlap or unoverlap. A key decision there is whether we allow overlap, meaning that bits from one sequence can start another detection, or non-overlap, where the detector resets after each detection. It repeats one by one detection. The next is overlapping versus non-overlapping. This is like two detection strategies produces different behaviors where patterns are repeated, where optimizing circuits efficiency and detection speed are the understandable. It partially repeats where this has two types, overlapping detector and non-overlapping detector. This overlapping detector reviews between bits consecutive patterns, faster detection of repeated sequences, more complex state machines. But non-overlapping resets after pattern detection. Non-overlapping detector simpler states transitions, one detection per complete cycle in a non-overlapping detector. By the diagram, we can see that it is a repetitive of overlapping. And next is mm, design methodology. And we have to discuss about some types of sequential detectors that I have discussed in the previous. There are two types. In an overlapping detector, the circuit can be reused with previous detection to find the next one. For example, in detecting 101, the ending in 1 of one sequence can serve as the beginning of the next. In non-overlapping detector, once a sequential is detected, the circuit resets to the initial state before search again. Overlapping designs is faster but is little more complex. It is more complex. And next is eight-step process. It is a methodology where design steps for sequential detector. It is known as design methodology. The systematic design procedure includes sequential circuit through careful state abstraction and logical implementation. Step 1. Identify the sequence to the detector. We have to identify the sequence where we have to detect it. So define states. Step 2. Define states representing the progress of detection. We have to represent the progress of detection. And fourth step is draw the state diagram. We know that state diagrams are very important, so we have to draw the state diagram. And step 4, convert it to a state table. By the diagram, we can convert the matter or information to a state table. And step 5 is assign binary codes to the states. We know that it's a basic language that binary and it has codes like 1 or 2 binary numbers. It is easy to assign codes to the states. And step 6 is choose flip-flop type, usually D or JK, not the T or latches. We have to choose only D or JK. Write the excitation of output equations. Step 7 is write the excitation and output equations. And step 8 is finally draw the logic circuit and verify it using timely waveforms or simulations. And we have to go to the examples for overlapping and non-overlapping. Here the example for sequence 1011. It is for example for overlapping. Let's make an example sequence 1011. We will define 5 states. So first is initial when no bit is matched, but in S1 1 is detected and S2 10 is detected and S3 101 is detected and step 4 is 1011 detected. The output becomes 1 when the mission reaches X4 because we allow overlapping. Some transistors go back to intermediate stages instead of the initial ones. So by the reaching the S4, the output becomes 1. And next example is for non-overlapping. Example sequence again take 1011. In the non-overlapping case, the same sequence is detected, but once the output is equal to 1, the circuit resets to the initial state. So this prevents using any part of the previous sequence in the next detection. Design trade-offs and key differences are there in this. By this, it prevents using any part of the previous sequence in the next detection. The non-overlapping designs is similar and easier to verify, but may miss sequences that occur close together. Here, simple logic, but slower detection and consecutive fewer states needed. Easier implementation of basic of hardware. Here, state tables and state assignment. After drawing the state diagram, we prepare a state table listing the present state input and next state and output and FF inputs. Here under the for instance, if we present state is S3, meaning we have a 101 or 3 digits and the next input bit is 1, the next state will be S4 and output is equal to 1. We know that. Then binary codes like 01, 01, 10, 11 are the possibilities of 101 are assigned to the states, so we can implement them using flip-flops. Next, get into next slide. Implementation of using flip-flops. Next, we select flip-flops. We use D flip-flops. The input to each flip-flop is equal to the next state bit derived from the state equations. From the state table, we write excitation equations such as d, d of a is equal to xb plus xb x bar b plus xb bar and d of b is equal to xa. For example, we then design the combination logic with AND, OR and NOT gates feeding the flip-flops. The resulting circuit performs automatic sequence detection. Slide 11 is timing diagram and verification. This verification, the slide shows that timing waveform of the detector. On the time axis, we have a clock pulse and the sequential input bits, the changing state variables, and the output. Whenever the sequence 1011 appears, the output pulse goes high. We can verify this behavior using simulation tools like multisim and quarters or logism or on a hardware trainer kit. The verification methods like simulation, hardware, logic analyzer, and manual trace. These are the methods we have seen in the verification. Next is summary and applications. To summarize, sequential circuits store past information to the recognized patterns in a data streams. Sequential patterns in a data streams. Sequential detectors are the special sequential circuits that output 1 when a specific bit sequence occurs. Overlapping detectors are faster, non-overlapping ones are simpler, and they are widely used in communication systems, circuit detection and protocol recognition, and embedded control. And any questions are there? Thank you for listening. And this is my topic selected in a seminar about in a 12 slides or 11 slides. Thank you for everyone.